Anyway, so hi everybody. My name is Fraser Cain. I'm the publisher of Universe Today, and of course we've got Pamela Gay, Dr. Pamela Gay, my co-host on Astronomy Cast. And if you've never seen this before, what this is a live recording of our Astronomy Cast podcast. This is this weekly podcast that we do. Where we pick a topic in space and astronomy and sort of cover it back to front, and then we stick around afterwards and we'll answer some questions that you might have about space and astronomy. So we're going to get going. We'll record the episode part first, and then when we're finished, we will sort of stick around for a few minutes and chat with you. So if you want to make any comments or questions or feedback while we're recording the show, there's a few places that you can do that. One is on YouTube. So if you're watching this embedded on YouTube, you can make a comment there. If you're watching this on Google+, you can just make a comment wherever you're seeing it on Google+. Or if you see it embedded somewhere and you want to use Twitter, you can just use the hashtag AstronomyCast, and we will catch that there. And then, in theory, we'll sort of, as you make comments and make suggestions and improvements, as I'll incorporate them into the show, and it'll sort of get that feedback going. And then afterwards, like I said, we'll stick around and answer your space and astronomy questions. So we're aware that we're very behind, and we have plans to sort of catch up a bunch of episodes. I've got nothing now for months, so
I hate you with love.
I get nothing. I can record Astronomy Cast episodes all day long, no problem. So Pamela will work with your busy schedule.
Yeah, no, my Tuesdays and Thursdays look fairly open, so we'll be catching up on shows.
Okay, yeah. So we got, I think we got about 8 episodes to catch up. So, but I got lots of topics. I mean, they're ready to go, and some cool ones too. So we just need to get cracking through them. Yeah. Okay. Cool. All right. Hi, Guido. I'm glad we gave you an unexpected surprise. All right, let's get rolling. Nicole, yes.
I love the live parts. Like, oh, you're crazy. We love you too, though.
Yeah.
Okay.
We can't call our listeners crazy. It's not appropriate, Pamela.
But in good ways.
All right. I'm ready. Are you ready?
Okay. Yeah, I'm pressing record. It's recording.
You sure?
Yeah.
Okay, here we go. Astronomy Cast, episode 294 for Monday, February 18th, 2013, Arecibo Observatory. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Good. Back from a epic 2-week vacation down the west coast of the United States. We went to Oregon and San Francisco and Los Angeles. I went to the Griffith Observatory. I went to NASA. I went to Pixar, the Natural History Museum. It was awesome. And now
and you did all of this with your kids, and you crammed in business and life and everything else.
Yeah, exactly. It's a business. It's a tax write-off. Yeah. So no, it was good. It was really fun. If you've never done that trip, if you've ever gone down the west coast of the United States, I highly recommend it. It's a beautiful chunk of the world. So
it really is. So is Western Canada and Alaska. So really, just like start
the whole
up
west,
Bering Strait and
but you can't drive. Yeah, you pretty much can't drive north of Vancouver along the coast like that. Yeah. So you got to take a ferry.
Oh, well. Okay.
But now you have an announcement this week.
I do. So we had great success last fall teaching a series of different classes through CosmoQuest. It's our Cosmo Academy program, and we are offering 2 more classes this spring. The first one is Stars and Stellar Evolution, or actually it's called The Sun and Stellar Evolution, but it's really stars. This is getting taught by our own Ray Sanders, dear astronomer, and that course runs from April 15th to May 8th, and you can sign up for it at cosmoquest.org/classes. There's a link to the Eventbrite page. And then we also have Dr. Matthew Francis, who on Twitter is Dr. Mr. Francis. It's really Matthew R. Francis, but really it looks like Dr. Mr. Francis. He's the director of our Cosmo Academy program, and he's in the process of writing a new book on cosmology and is bringing his expertise to the classroom. He's going to be teaching an introduction to cosmology class. Both these classes are limited to just 8 people, so this is a very intimate experience. Nicole Gallucci and I will pop in and out on a regular basis. And so if you're interested in learning and you have spare money to take some classes, we're sorry, we can't do this for free.
Yeah, there is a fee for these. Yeah.
We have to pay our instructors. But these are chances to learn from people active in astronomy and who are solid communicators of astronomy. So please sign up, join in, and I hope to see you in our classroom.
And it's all done in a Google Hangout, right?
Yeah, so we do everything through Google Hangouts.
Yeah, and that's great. So only 8 slots with each one, and I know they're going to fill up fast. So if that's in any way interesting to you, go and sign up. Is there a different fee for each one? Is there a...
No, it's both the same fee. And to be entirely honest, in trying to figure out what to charge, I looked at the typical prices of yoga, horseback riding, ballroom dancing, and piano lessons.
Right.
And we are completely competitive with any other sort of extramural class you might take.
Okay. Well, let's get on with the show then. So the mighty Arecibo Radio Observatory is one of the most powerful radio telescopes ever built. It's certainly the largest single aperture radio telescope on Earth, nestled into a natural sinkhole in Puerto Rico. We're celebrating the 50th anniversary of the construction of the observatory with a very special episode of Astronomy Cast. 50 years.
Yeah. It's kind of awesome that we've been building monstrous facilities like this for so long, and it makes you really think back to the fact that 50 years ago, well, that's not too different in time. It's the same generation that built the Hoover Dam, that built the St. Louis Arch, that built all of these giant works programs across the United States. And one of these giant works programs was building a giant radar dish out in Puerto Rico. And it took about 10 years to sort out all the details of what was needed, and it was finally opened in November of 1963. And we're still using that sucker today. It's constantly getting updated both on the software side and, as monies allow, on the hardware side, so that it continues to be a competitive facility capable of doing science that nowhere else in the world can the science get done.
Now, it is a very special instrument. So can you sort of explain a bit about if you were to, have you ever visited it?
No, I haven't.
No. What is it? And I know we've seen it in movies and film and stuff, but what is the observatory? Because it's pretty neat.
Well, at the most basic level, it's nothing more than a satellite dish like you might use for getting television and internet. It is capable of both sending and receiving radio waves. But what makes it special is this sucker is huge.
Mm-hmm.
There's really no other way to put it. It is 300 meters or 1,000 feet in diameter. It's built into a natural sinkhole in Puerto Rico, which is actually part of why we chose to build it there. Was you don't want to have to dig a hole for something like this.
1,000 feet across. Yeah.
Right. So they found a natural hole. And it's a spherical spherical reflecting surface. And this is actually very important. When they were first working on designing this, the initial design was strictly to use it to study the atmosphere. And they were originally going to build a parabolic, a mirror that only focuses at a single place above the reflecting surface. And that would mean that it could only observe straight up. Now, that really limits what you can see, especially since planets aren't necessarily going to be directly above this object. So as the project continued to move forward, they actually put out a request for proposals on how can we redesign this so that you can actually look at different parts of the sky without being able to move the dish. You can't move 1,000-meter dish or a 1,000-foot dish, 300-meter dish. It's just, that's a lot of mass, and it would deform as you moved it.
Right.
So they've built this beautiful system out of aluminum sheets. They're suspended on a network of cables, and by switching from a parabolic mirror that only focuses in one place to a spherical mirror that has the exact same edge image issues everywhere you point, you can actually, over a spherical dish, move your focus point around, and as far as it's concerned, there's still part of a sphere below it. But then you have to figure out, how do you suspend that thing that you're moving around so that you can move it so carefully, so gradually, that you can track the Earth's rotation precisely. And the system that was eventually devised, there's a series of pillars. It was designed with 4. They only put up 3 because that's what they realized was all they needed. There are these 3 towers that have cables coming in, and they suspend the receiver for the system, and they can move the receiver around on a series of tracks. And it's all extremely precise. And what's really funny is all of these bits and pieces have an acting role in the GoldenEye James Bond movie, except instead of pointing at distant quasars, they're pointing at a nearby satellite that's going to like blow up the Earth or something.
Right, and they need to fight on these various parts of the observatory.
Right. It's really kind of funny.
So, this is a bit of a mega project. It was probably a very complicated and very expensive undertaking to make something that large.
Yeah.
What was the original science goals of the observatory? What did they plan to use it for?
Originally, they were just looking to study the Earth's atmosphere. You can bounce radio signals off of our atmosphere, and depending on the wavelength of the light, they'll bounce off of different heights in the atmosphere, and based on how they come back, you can measure the turbulence pockets, the cells of different atmospheric characteristics as it goes up. So it's a very detailed way of observing all the different layers in our atmosphere. But then as they work to redesign it to allow tracking and guiding, they added in the ability to do active radar, to bounce radar off of nearby planets the same way we might image a satellite orbiting the Earth with radar, or heck, police radar beam things all the time.
Right, so you're using it to transmit radio waves at a surface and then detect the bounce back from that surface, which is amazing. To be able to send, it's a transmitter.
And what's kind of cool is, up until Arecibo was up and working, we didn't actually know accurately the rotation rate of the planet Mercury. It was only in 1965 that we realized this little world wasn't as tidally locked the way we thought it was. So it turned out, we figured out from the radar returns, that it rotates every 59 days instead of the previously thought every 88 days. So just a few years after its opening, it was already completely changing how we looked at nearby planets. And in fact, it was the instrument that was able to provide us our first maps of the planet Venus, admittedly only at a resolution of 1.5 kilometers, but it still mapped Venus in radar light for us.
But you can't move that observatory at all. You can only move that detector array that's above it, right? So, for example, if they wanted to observe the surface of Venus, how would they do it?
So luckily, they built this observatory fairly near the equator. Puerto Rico is a nice equatorial island. And that means that it's looking up at that part of the sky that all the planets occupy, for the most part. The sun and the planets all vary back and forth from plus or minus roughly 24 degrees in between the tropics of Caprica and Cancer. And luckily, this observatory, by moving the receiver around, the receiver is able to look at light that's coming in at a different angle depending on where they put it. And by steering the receiver around, they can actually look at objects within plus or minus 45 degrees of straight overhead. That gets them all of the planets, and it gets them a good chunk of the sky. And truth be told, any observatory, you really aren't going to be pointing the telescope more than 45 degrees down from straight overhead, because you're just looking through too much atmosphere if you do that. So even though you can't move the base of the telescope, you can move the receiver and still steer around on the sky.
So it's possible then, obviously, to get I guess the radio emissions from Venus, coming from Venus, they bounce off that spherical array up into the actual detector, which has been positioned to get that image. But how do they actually look? I'm putting air quotes in the video. How do they look at Venus? Because it's radio, right? So it's not
Right.
it's not like you're going to like look through your
Yeah,
lens, your eyepiece at this image, this radio image of Venus. So
well,
what are they actually seeing?
it's even crazier than that. The thing people don't really think about with radio telescopes is this is a single pixel detector. You are
One
looking
pixel.
1 pixel. So you have to move the beam around on the object, and it's by recentering that 1 pixel over and over and over that you're able to build up the image. So it's kind of a longer, more elaborate process than what many of us are used to. But with Venus, the way they do it is they actively shoot radar beams at Venus and then measure how long it takes for that signal to get back. And by shooting these beams of radar at Venus over and over and over, they can build up the elevation differences from place to place across the surface. And one of the kind of frustrating things is this is a very powerful device, so we could conceivably use it for more than just the nearest planets, but we run into this problem that objects like Saturn, the amount of time that it takes for the radar signal to get back is so long that by the time the light has gotten back, Saturn's no longer in the field of view of the telescope.
Right. I mean, you can just imagine the math here. I mean, they're detecting elevation differences on Venus that could be a few, 1,000 meters less, probably. And they know, and it takes light, I don't know, 4 minutes, 2 minutes to get to Venus and then back, and Venus is moving, and Earth is moving, and Earth is rotating. I just can't imagine how complicated it is for these people to do this work. It's insane.
It's just geometry.
It's merely really, really complicated, advanced geometry. That's all.
Yes.
Yeah. So anyway, kudos. So okay. So I mean, it's mapped the surface of Venus. It's determined the speed of orbit, speed of rotation of Mercury. But I think when a lot of people see the Arecibo Observatory, they think contact, they think aliens. They think search for life. So how has it been sucked into that project?
Well, truth be told, it was actually used for the SETI at Home project. So if you remember back in the 90s, there was software that you can install on your Windows system that would go through when your screensaver was on and download information from the University of California, Berkeley, and then it would process that information on your computer. It was one of the first citizen science distributed computing projects. And the software that was used has continued to be maintained, continued to be updated. That core software is called BOINC. And SETI at Home spawned a variety of sister projects, including Einstein at Home, which is going through that same data, some of which was taken with the Arecibo Observatory. And while not every survey is going to turn up aliens, and in fact none of them have so far, what they are finding is pulsars. And so there's this diversity of research that can all come out of the same data, all using distributed computing to get the job done. And
did they find anything yet?
No.
No. All right. Now, have they tried to use it as a transmitter to look for aliens?
They have. Back in 1974, there was a message that was sent out in ones and zeros that included what can best be described as a really dorky image. I'm not sure how else to put it. It was called the Arecibo message, and it is trying to communicate towards the globular cluster M13, which admittedly, if the signal reaches M13's dead. So that was a strange choice of destination.
But aren't there like a ton of stars in there, so you never know?
Well, the thing is, that's actually looking up out of the solar system, so there's not that many stars between here and there compared to other directions they could have chosen.
Right.
It was a 23 pixel by 73 pixel bitmap image, which is harder to say than one would wish, of chemical formula, of the telescope itself, and stick figures. It basically mirrored the highest resolution video games of 1974.
Yeah, exactly. When you look at this image, you're really seeing, something that looks like Space Invaders.
Yeah. Yeah.
So I think that's pretty funny. But
or a guy with his head in calipers of some sort is very strange.
So yeah, no, it's a pretty funny image. But I think the point was they were trying to get across sort of with as much information. They were trying to show like the decimal, that we understand the decimal system, that they're trying to explain the planets that we have, what we kind of look like, and what instrument we use to communicate this message. And they all encoded into this 8-bit image, and that would look appropriate on a video game. So pretty clever, I think. On a complete side note, when I was at NASA JPL, I got a chance to see the golden record that's attached to the Voyager spacecraft, and it's that same concept. And there's also the ones that were attached to the Pioneer, but it's that same idea. It was like, how do you communicate to space aliens anything? And so, you start with math, and you're like, we understand pi, and we understand these various, we understand E, we understand these basic fundamental numbers, and then try to build up from there. And the laws of physics, hopefully, will be the same for the aliens as they are for us. So
one hopes.
And I think that was the message in Contact, right?
Yeah, and that was one of the awesome things about Contact is they looked at it from the perspective of how do you actually break this down? If someone was sending a signal, if we were sending a signal, what are the different things you'd want to encode? And at a certain level, you have to take advantage of the fact that transmissions can be along multiple resonance wavelengths, that you can have signals encoded within signals in a certain way. So if you think about it with television, they're encoding X and Y positions of each little color for the television as well as the soundtrack. And so there's also the sub-captioning. All of this gets encoded together. And so with Contact, there was at one level pi coming out, and then at another level there was video coming out. At another level there was this great grand instruction manual. And so Contact really, Carl Sagan took to the greatest extreme, what are our hopes and dreams made manifest by another civilization. And he did base the lead character, the one that was played by Jodie Foster, on Jill Tarter, who was the director of the SETI Institute until recently, when she stepped sideways to focus on getting the Allen Telescope Array going and focusing on science. So it's a very realistic depiction of what it means to be a woman in science, and what in its time we might have aspired for.
Now, I know that there are, that's with the Arecibo Observatory, you've got this strategy of like one really big radio telescope, a super telescope, and it's that same concept with, the James Webb Space Telescope. Like, let's just pour a bunch of money into something really big, the Hoover Dam of radio telescopes. But a lot of the work now in radio astronomy is with these arrays, these distributed arrays across in fact, the entire Earth. Now, can the Arecibo array join these global connections?
It depends on what science is being done. A lot of the smaller dishes work at slightly different wavelengths than Arecibo, but when they're working at wavelengths or frequencies that are compatible, yes, you can combine the light. It's a pain. You have to do all sorts of things like what's called fringe finding, where you work to adjust the time separation between the different facilities. But yeah, it can join in. The great thing about radio signal is you can combine it after the fact, unlike optical light, because we can actually record each and every incoming wave. We just can't do that with optical light.
Now, because it's an instrument, a telescope observatory in astronomy, I'm going to assume it's severely underfunded and constantly under risk of being canceled and
Yeah.
and in disrepair. So, how's it doing on that front?
Well, it's actually currently doing just fine. It is a jointly funded facility. It receives funding from the National Science Foundation, from NASA. It's administered by Cornell University. And the reason that it's been able to survive is every time they try and cancel it, which happens on a regular basis, scrambling occurs, and eventually someone steps up and somehow the money is received. So for instance, in 2009, they were able to get $3.1 million from the stimulus funding that came out for shovel-ready projects. Just things like that keep happening over and over across time. And today, the diversity of things that it can do are such that it would be somewhat foolish to cut it off. So it's done a very good job at making itself required. With that big of a surface area, you can detect extremely faint signals that you can't detect with the distributed arrays of telescopes. Those distributed telescopes have amazingly high resolution, but each dish can only collect so much light. One giant dish can effectively listen for the weak signals of spacecraft all across our solar system. It can also get used for active radar on asteroids, imaging asteroids as they pass by, which is kind of something we're interested in, considering asteroids can hit us. And it just has all of these different things. They've worked on redoing the surface, allowing it to go first down to a wavelength of 60 centimeters, then down to, 6 centimeters, and then down to 3 centimeters. And by getting to these very small wavelengths, they're able to get increasingly higher resolution images, because the resolution is determined by how many times the wavelength fits across the diameter. So you have this great combination of huge collecting area allowing you to see fainter and fainter objects, and huge size that, as they're able to perfect the surface and perfect the receivers to detect shorter and shorter wavelengths, they're able to detect things at a higher and higher resolution.
Yeah, I mean, when you hear people talking about the fact that they're going to shut something down or stop maintaining, you just kind of look at it's an enormous scientific instrument that cost hundreds of millions of dollars to build and is producing tons of amazing science. How on earth could they cancel that kind of a project? It's the same thing when they talk about they're going to cancel Voyager and things like that, and you're just like, it was billions. It's out in space. It's sending back data still. Like, you can't cancel it.
Well, I wish. The fundamental problem that we're running into, though, is NASA's budget, for the most part, has been getting flatlined for many years. And when you look at a flat budget in a situation where we do have inflation, that means you actually have a decreasing budget over time. Now, take a decreasing budget and now increase the number of facilities that are trying to draw funding from that budget. And what you have is something has to give, and it's turning out that they're doing things like restricting travel, canceling conferences, making staff work more hours because there's simply fewer staff to accomplish the same amount of work. And eventually something is going to have to close. And right now we're in the process of trying to figure that out. Arecibo seems to be safe, but long term it won't necessarily stay safe, simply because as we add the Large Synoptic Survey Telescope in, telescope after telescope, Atacama, this all eats away at our declining resources. And it's the people who are getting fired every time we try and save a telescope, which means you have fewer scientists to do the science with these amazing instruments.
Right. So do you think there's going to be a follow-up observatory like Arecibo? Do you think there will be something else ever built like it?
No, I don't see that happening. And I think this is because we're starting to focus more and more on different types of telescopes. The square kilometer array that's getting built partially in South Africa and partially in Australia is going to be looking at extraordinarily long wavelengths using distributed array network, distributed distributed antenna networks spread out across multiple countries in South Africa, actually. The Atacama telescope is looking at the shorter wavelength parts of the sky. And so as we build new facilities, they're being built to have capabilities that complement Arecibo but don't replicate it. So we're trying to diversify what we can do, and Arecibo is unique and it fills a unique niche. And as long as it keeps working, we'll build different things that add to what we can do.
So we won't, for example, go and build a big observatory in a big crater on the moon and, 3 kilometers across.
That is something that people try and bring up as a potential idea to do. It would have the advantage of being sequestered from the radio signals coming from the surface of the planet Earth if you built it on the far side, for instance. But right now, the funding necessary to do that is well, Charlie Bolden came out and said in the past couple of days, he's the current administrator of NASA. He said that the United States will not be the primary country on a manned mission to the moon in his lifetime.
Whoa.
Yeah.
That's sad.
So I kind of doubt that we're going to be having the manpower to go build these mammoth facilities. Now, some other nation might, but I haven't heard it talked about.
Well, happy 50th anniversary, Arecibo. Thanks for all the science and all of the amazing backdrops for all of those cool movies.
And it doesn't ever fill with water. It has a perforated thing, so that whole scene where they fill it with water. No. And it's not in Cuba. It's in Puerto Rico.
Yeah.
And it's been in many, many other bad sci-fi movies. So we realized that we didn't acknowledge things like Survivor, not the TV show, the movie. And we know that it's been in a whole bunch of different books, including one of my favorite, The Sparrow by Mary Norris Russell.
You can do a search in the Internet Movie Database for Arecibo, and it'll show up every movie that it's been an actor in. So awesome. All right. Well, thanks, Pamela, and we'll talk to you next week.
My pleasure. Thank you. Don't go away. We're just saving. And I should have done this while I was still recording, but Preston, our audio editor, is in the process of writing his master's thesis. And so we're all very proud of him.
What's it on? Astronomy Cast?
No, it's not, but it is on radio film.
Cool. Okay. I'm safe.
So Mark Antonenko is asking, what day is that today? And I'm not at all sure what you're asking.
Well, we're talking about I think the 50th anniversary, right? Was it the...
right, sorry.
It was in November?
It's Max, not Mark. I mispronounced it. Max Antonenko. It's November 1st, 1963 is the date that it opened up.
Omar Torres says, my radio telescope, born and raised Puerto Rican here. I always stared at it in awe when I was a little kid. I am super jealous that you've had a chance to see it with your own eyeballs. And
I haven't.
I've got it. No, Omar.
Oh, yeah.
Yeah, in Puerto Rico. So I am super jealous. So I will have to put that on my bucket list. I actually just I just crossed something off my bucket list on this trip. Yeah, well, a couple of things, but one was to see the spruce goose. So when we were in, this is the big flying boat that was created by Howard Hughes.
Yeah.
Yeah, and it's it flew for less than a minute for less than a mile, and it's a phenomenal aircraft, completely made of wood. It's gigantic. And
it's a boat.
It's a boat, but a flying boat. Although that's not very well, but still amazing. The facility it's in McKinleyville, just outside of Portland, and it is absolutely world class. I would say it is the finest air and space museum I've ever seen, and I've been to a bunch. The Smithsonian, it's giving the Smithsonian a run for its money because there's a lot of really amazing stuff. But in the McKinleyville one, there's a Titan IV rocket, there's an SR-71 Blackbird, there's a ton of spacecraft landers, there's a big Apollo lander there, there's lots of spacecraft. It's a really great place, plus the Spruce Goose. So if you're in the Portland area or Seattle area, and you haven't seen that Air and Space Museum, go. It's great. And take the whole day. I mean, it's gigantic. You're going to need a whole day. And there's an indoor water slide park that the kids really like too. So
You don't have children. You have otters.
I do. Was anyone able to? Okay, so Wesley DeFleta asks, did anyone was ever able to decode the Arecibo message without knowing anything about it? In my opinion, it seems to rely too much on the person's knowledge to be recorded. Same for the Voyager disk. So right. So the question is, did they attempt to show? Have they tried to get a person who has no idea what this message is about to decipher it? And they must have spent some time, and when they created those messages and the golden record.
I'd really love to give a communications class that as their first homework assignment, just to see what would happen.
Yeah.
That's an excellent question. The fact that it has a certain number of rows and columns is always, well, how did they encode that?
Mm-hmm. But you can imagine going into Papua New Guinea and finding some tribe that doesn't have a lot of connection. Maybe the mathematician of the bunch, and say, okay, so what do you think this says?
That's not going to work. No, yeah. You really have to assume someone with advanced knowledge, but not knowledge of that.
Right. Yeah. So go to some mathematician or someone who had never heard of that, and see if they could understand what the message is saying. Franco Moore asks, what was Arecibo's greatest discovery? I'm going to say... Pulsars. No, yeah. I'm going to say the first extrasolar planets.
Oh, that's true. It did find the first extrasolar planets around a pulsar.
Around a pulsar, yeah. This is by Alexander Wolskan, and they were 3 Mercury-sized planets that were Pluto, even Pluto-sized, orbiting this pulsar. And I think we always go back because that is really the first extrasolar planets that were ever discovered. And
it's one of those things that really leads to people arguing over what planets are, because do these remnant bodies that survived a supernova explosion actually count as planets or as debris? And so that's just an interesting question. KKM121 asks, now that we can connect many small dishes together to form a giant telescope, is there any more need to build single giant dishes other than to image asteroids? So now you mentioned, you sort of got at this a bit, right? That it's the difference between resolution and sensitivity. And so with a big observatory, you're going to get a lot of sensitivity. With a lot, you're going to get the resolution. In a perfect world, there's a need for both, right? Yes, we do need both. So that's we've got the big ones, so let's figure out how to build the smaller ones in better ways. But they could make, in a perfect world, a bigger one would be better. Yeah. The sucker's 300 meters across. It was done. Now it's time to figure out something bigger. That's all I'm saying. Right? What about, hollow out, there's the Diablo. We're not putting it in a volcano crater. No. What about the one in Arizona, the Diablo, the meteor strike? The meteor strike, yeah. It's pretty big, right? I think the scientists would object a bit because they kind of like to study that asteroid impact. They'd be torn, right? Because meteorites, but huge radio observatory. Yeah, right. We still don't have the money, so it's not. It's a mute question. Right, but the point being, things like the square kilometer array is the direction they're going now. Yeah. And connecting all of these telescopes into a worldwide array. Yeah. is good. Graham asks, how much did Arecibo get for starring in those movies? I wonder if they got money. They were paid, but I don't remember how much. Yeah. Actually, one of the really funny things is, so Contact was filmed at both Arecibo and at the Very Large Array in New Mexico. And when you go to the control room of the VLA, the picture that's autographed by Jodie Foster that they have is her at Arecibo, to which everyone is slightly bitter. Right. She should have done 2. Someone find her. I think that's it. And I know we've got to go. We got a meeting in 8 minutes. So yeah. Why don't we wrap this up? Okay, cool. All right. Well, so thanks, Pamela. And thanks, everyone, for watching. Expect a bundle of shows in the next couple of weeks, we hope. So, yeah, with interesting topics. So we will we'll get cracking on that. So we'll talk offline, Pamela, and schedule the next one and commit and catch up. All right. Sounds great. I'll see you in a few minutes. Yeah, okay, cool. All right. Hi, Guido.
I'm glad we gave you an unexpected surprise. All right, let's get rolling. Nicole, yes.
I love the live parts. Like, oh, you're crazy. We love you too, though.
Yeah.
Okay.
We can't call our listeners crazy. It's not appropriate, Pamela.
But in good ways.
All right. I'm ready. Are you ready?
Okay. Yeah, I'm pressing record. It's recording.
You sure?
Yeah.
Okay. Here we go. Astronomy Cast, episode 294 for Monday, February 18th, 2013, Arecibo Observatory. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville. Hey, Pamela, how you doing?
I'm doing well. How are you program? And we are offering 2 more classes this spring. The first one is Stars and Stellar Evolution, or actually it's called The Sun and Stellar Evolution, but it's really stars. This is getting taught by our own Ray Sanders, Dear Astronomer. And that course runs from April 15th to May 8th. And you can sign up for it at cosmoquest.org/classes. There's a link to the Eventbrite page. And then we also have Dr. Matthew Francis, who on Twitter is Dr. Mr. Francis. It's really Matthew R. Francis, but really it looks like Dr. Mr. Francis. He's the director of our Cosmo Academy program, and he's in the process of writing a new book on cosmology and is bringing his expertise to the classroom. He's going to be teaching an introduction to cosmology class. Both these classes are limited to just 8 people, so this is a very intimate experience. Nicole Gallucci and I will pop in and out on a regular basis. And so if you're interested, how are you doing, Fraser?
Good. Back from a epic 2-week vacation down the west coast of the United States. We went to Oregon and San Francisco and Los Angeles. I went to the Griffith Observatory. I went to NASA. I went to Pixar, the Natural History Museum. It was awesome. And now
and you did all of this with your kids, and you crammed in business and life and everything else.
Yeah, exactly. It's a business. It's a tax write-off. Yeah. So no, it was good. It was really fun. If you've never done that trip, if you've ever gone down the west coast of the United States, I highly recommend it. It's a beautiful chunk of the world. So
it really is. So is Western Canada and Alaska. So really, just like start
the whole west,
Bering Strait and
but you can't drive. Yeah, you pretty much can't drive north of Vancouver along the coast like that. Yeah. So you got to take a ferry.
Wow. Okay.
But now you have an announcement this week.
I do. So we had great success last fall teaching a series of different classes through CosmoQuest. It's our Cosmo Academy.
Anyway, so hi everybody. My name is Fraser Cain. I'm the publisher of Universe Today, and of course we've got Pamela Gay, Dr. Pamela Gay, my co-host on Astronomy Cast. And if you've never seen this before, what this is a live recording of our Astronomy Cast podcast. This is this weekly podcast that we do where we pick a topic in space and astronomy and sort of cover it back to front, and then we stick around afterwards and we'll answer some questions that you might have about space and astronomy. So we're going to get going. We'll record the episode part first, and then when we're finished, we will sort of stick around for a few minutes and chat with you. So if you want to make any comments or questions or feedback while we're recording the show, there's a few places that you can do that. One is on YouTube. So if you're watching this embedded on YouTube, you can make a comment there. If you're watching this on Google+, you can just make a comment wherever you're seeing it on Google+. Or if you see it embedded somewhere and you want to use Twitter, you can just use the hashtag AstronomyCast, and we will catch that there. And then, in theory, we'll sort of, as you make comments and make suggestions and improvements, as I'll incorporate them into the show, and it'll sort of get that feedback going. And then afterwards, like I said, we'll stick around and answer your space and astronomy questions. So we're aware that we're very behind, and we have plans to sort of catch up a bunch of episodes. I've got nothing now for months, so
I hate you with love.
I get nothing. I can record Astronomy Cast episodes all day long, no problem. So Pamela will work with your busy schedule.
Yeah, no, my Tuesdays and Thursdays look fairly open, so we'll be catching up on shows. Okay,
yeah, so we got, I think we got about 8 episodes to catch up. So, but I got lots of topics. They're ready to go, and some cool ones too. So we just need to get cracking through them.